Alright, so if you're watching this video, it's probably because you want to know a little bit more about how you can make sure that you are able to solve a system with some of these methods. Three of the basic methods for solving a linear system would be by substitution, by graphing, and by combination, which might also be called elimination or often called the adding method. What I'm going to focus on right now is substitution. So let's take a look at a system that might be probably most easily solved using substitution. So y equals 2x plus 3 and 2x plus 5y equals 27. So these two linear equations together form a system. Remembering that a system is anytime you have two or more equations that are often working together somehow. So when I'm looking at this, I'm thinking, well, I have these three methods: substitution, graphing, or combination. The first one would be really easy to graph. The second one, not as easy. Substitution really stands out to me for this one. And the reason substitution stands out is because this first equation literally says y equals, and then this, right, 2x plus 3. It's saying that y equals, meaning y is the same thing as 2x plus 3. Well, that's kind of cool, that y is all by itself, and I now have another way that I can write y, because whether I'm saying y or I'm saying 2x plus 3, I'm really saying the same thing. Alright, well, if that's true, then let's rewrite the second equation. 2x plus 5y. Now notice, I'm not going to write y. I'm going to say y. 5y equals 27. But now here comes this idea of substitution. Rather than writing y, I'm going to write something that I know is the same as y, or is equal to y. I got that information back up here. 2x plus 3. That's the same as y. So 5 times y, but look what I just wrote, 2x plus 3, because in this case that's the same as y. Now I have just substituted. Alright, I've just substituted. Instead of y, I put in 2x plus 3. From there, I'll solve. So let's just be careful. 2x plus 5 times 2x plus 3, so that means I'm saying 5 times 2x, but I'm also saying 5 times 3, and both 5 and the 3 are positive, so 5 times 3. I've just distributed that 5. Alright, still just making sure I'm being careful, so 2x plus 10x plus 15. That's 12x. Now to solve, I'm going to subtract that 15 from both sides of the equation. So on the left side, 12x plus 15, subtract the 15, I now have 12x. And 27 minus 15 is 12. Alright, cool. So if 12 times x is 12, I know x has got to be 1. I could show it by dividing both sides by 12, but I also can just think about this and know 12 times what number is 12? Well, 12 times 1 is 12, so x has to be equal to 1. Well, that's great. Now, I'm only halfway done at this point, though. If I'm looking for a solution to the system, I know that there are two variables. Both of them are unknown, right? I need to find x and I need to find y. In this case, I found x, so that's great. So x is 1. I'm going to write that there, remembering that this is these ordered pairs are always written as x comma y. So x is 1 and y, I'm not sure yet, but I remember y is equal to 2x plus 3. Y and 2x plus 3 are the same thing. So I could find out y by finding out a value for this expression 2x plus 3. If x is 1, then I'm thinking here 2 times 1 plus 3. 2 times 1, because I found out that x has to be 1, plus 3. So that's 2 plus 3. Y has to be equal to 5. Y has to be 5. I'm pretty sure this is the right answer, but I'll tell you, it's always good to just double check, right? So if I were taking a test and I want to make sure I got the right answer, I would do that. So I know that 1, 5 for x equals 1 and y equals 5 works for the first equation, but I want to make sure it works in the second equation because that's what a solution to a system should do. It should work in both. So 2x plus 5y equals 27. Is that true when x, y is equal to 1, 5? Let's take a look. So 2 times 1 plus 5 times 5, is that equal to 27? I believe so. 2 plus, that's 2 times 1 is 2, plus 5 times 5 is 25. Sure enough, right? 2 plus 25 is equal to 27, so I'm a happy camper. The solution 1, 5 works for both of the equations that we were given in the beginning. So we have solved this using the method of substitution.